Hier wird statt die Luft anzusaugen, weil der Motor läuft ja noch nicht, müssen wir ja hier den Unterdruck erzeugen. Deswegen öffnen wir das Ventil und fließt. Hier steht im Vergaser der Unterdruck, den normalerweise der Motor erzeugt. Der Reaktor wird gezündet. Dann müssen wir dieses Manometer hier beobachten, an der Stelle da unten. Der Unterdruck soll konstant sein. Wir sollen das Ventil nicht schlagartig öffnen, sondern ganz langsam. Jetzt geht das nicht, weil das offen ist. Und deswegen hat Jim immer hier gestanden. Er hat mit einem Auge auf dieses Manometer da unten geguckt und auf der anderen Seite die Temperatur beobachtet. Okay. Und das soll recht langsam gehen. Wir dürfen nicht zu stark öffnen, sonst verbrennt das zu schnell da drin. Und dieses Ventil soll man nicht öffnen, nur wenn er die Flamme zurückholen will, dann kommt hier mehr Sauerstoff rein. Die Flamme zurück. Wenn hier die Temperatur den Wert erreicht hat, den er sich wünscht, dann schließt er das Ventil. Das haben sie ja mal recht schnell gemacht. Schließt er das Ventil und dann öffnet er das. Jetzt entsteht hier ein bisschen Druck und dann startet er den Motor. Der Motor saugt dann über den Ansaugstutzen das Gas aus dem Filter von dieser Stelle. So. Der obere ist in der Pyrolysezone, der untere in der Reduktion. Beide sollten um die 800 Grad haben. Wenn die 800 Grad haben, dann können wir den Motor starten. Dann müssen wir beide Temperaturen auf dem Display uns angucken. Wenn die Difference ist going up, wenn die Temperaturunterschied, when it's going lower in the reduction zone, then you shake the brake.
Between 20 and 100 degrees.
Yeah, that's kind of the range that you want to see it at. And if you see more than that or less than that, you can kind of diagnose what the problems might be, either by shaking the grate or adding more fuel into the reactor.
When it's going higher here, then we must add fuel. Wenn die Temperatur oben zu viel wird, dann ist zu wenig Brennstoff da, was nachläuft, dann müssen wir nachfüllen. Können wir eigentlich ausmachen denn. Und wenn es unten zu kalt ist, dann müssen wir rütteln.
Okay. Okay.
And yeah, and when they start to come together too, if they come together and are the same temperature, then you want to shake the grate. And that'll settle the charcoal and the ash through and kind of separate your zones again.
So they don't have to have both the same temperature?
No, you want them different. You want this one slightly lower than this one.
How much? 120?
20 to 100 degrees.
20. Also hier muss ein Temperaturunterschied sein. 20 bis 100 Grad. That is 800, that must be 700.
You'll typically see around 850 to
850 Ohm bis 860 und
and 8 to 820.
800. Also 50 Grad Unterschied. 50, 60 Grad. 860 Ohm und 820 unten.
One, you're reading the reactor.
Differenzdrucksensoren.
So you're reading the top of the reactor and the bottom of the reactor.
Also der erste ist an diesen beiden Messpunkten, oben und unten. This is the same as a manometer.
That's what you're reading on the manometer.
Okay.
Yes.
So you take care to the manometer right here is more important. Is the sensor, it's this sensor.
Yes.
Okay. Also wir gucken lieber auf dieses Manometer immer, als den Sensor zu verfolgen. And the second one?
They're both on the reactor. So this one is testing right at your grate here, and this one is testing up here.
It means that there are not differential pressure, there's only pressure sensors. Both.
Well, they're both pressure, but they're also differential. So you want to see a difference.
Okay. But it's the same function as a manometer.
Yeah, at least. Yeah, I mean that's what's making the manometer work.
Also die beiden Sensoren machen genau das gleiche wie das Manometer.
Okay.
And you want to see a difference. If you see a very drastic difference, it means that it's plugged, and there you have some plugging in your the reduction valve. So that's another way to diagnose if everything's functioning properly inside.
Then you must open the reactor and clean.
If you see a huge drastic difference and then your temperatures start going crazy, then you want to shut it down, open it up, and clean it out.
And when we want to stop immediately the on, what have we to do?
You just have to plug everything, turn all the valves closed, and put caps on everything so no oxygen can get into the system.
No oxygen.
And it'll just snuff itself out.
We come here, this is very hot at this moment. It will be
well, this will be off. Yeah.
We cannot close this then.
You would, if you were shutting it down, you would close this.
We must.
Yes.
Because otherwise.
Because this is the only thing, the only spot on the whole unit that should be open while you're running.
Doesn't it make more sense to have here a valve? For doing this immediately?
Yeah. You could have a valve there. You would want to maybe extend it off a little
Wir machen hier ein Ventil dran. Weil das muss zugemacht werden, wenn man ist. Da können wir nicht anfangen hier rumzuschrauben. Ja.
I might actually have a valve.
Ja, kalt ist.
Nee. Du gehst doch hier nicht gerne dran, wenn du ja nicht weißt, was da ist.
Ja.
Du! Mann.
So, noch fun.
Du!
Immer.
And that's dangerous right now because it can shut off, and then if you don't see it, you run out of fuel in there. So we have a different type of breaker here that resets, so we need to switch that out. So it's something that you should watch right now. If it shuts off, you have to turn it back on.
The alarm will be notifying us if the oxygen.
Okay.
So I should it off now?
No, leave it on. And when you're ready to go, you turn it on and leave it. Can you start a list on that? Okay.
Then I can have a look at the temperatures right here. Now I have to know which point is it.
Yeah, so T0 is combustion and T2 is the bottom of reduction. So those are the ones we're going to watch. Yeah. Those are the ones we're going to watch as we start it. Okay.
Oben, unten. Hier sind mehr Temperaturen, die braucht man nicht. Jetzt kommen die Pressure Sensors. Das wird dann oben sein. Das ist on top, this one.
Yeah.
And this is on the bottom. This one.
Four. The other ones don't have anything hooked up, so they're getting errant readings.
But we are looking at the temperatures right here. Oben, unten, and to this one, to the manometer. You see the differential pressure.
Yeah, so I mean, I use the manometer mostly as I'm running it. It's easier for me to read than this. And do you know the points that you want to do it as you're starting?
No.
Okay. So when we're starting through the lighting hole here, we like to pull it at about 1 or 2 inches of water. If you pull it too hard, it will overrun that little spot you're trying to light.
You do this by moving
This.
You must open this valve
Correct.
right now. This must be closed.
Correct.
This must be closed.
Correct.
I believe I could.
And so when you start that, when you start it, you want to make sure that you're staying out of the stuff that comes out here. Because there's still going to be gas in the system from when you ran it before. So you'll start to get stuff coming out. So the best way to start it is to have a fire in here, and then someone else, as it starts to go,
Someone else.
put something on here. Or have it oriented in the wind such that it's blowing away from you.
Oh. At the moment, also da müssen wir ja immer von der Seite, deswegen steht er immer an der Seite hier. Aus Sicherheitsgründen müssen wir das so immer machen und dann muss man dann so auf das Manometer schielen. 2 Inches ist ja so viel, wa? The difference is so.
Yeah, you want to
see it about here in this range here. Because this is 5, 10, so you would want it.
Make a marker here. So let me see how much yet to open.
But you don't want to do it until we're lighting it. So, Holger, you don't want to be near this or breathing. Your head doesn't want to be close.
Hi.
Holger, let me tell you something more generally about this. Okay, the main running range is between 0 and 10. Okay, the reactor works well. The ideal point is like in the 4 to 6 range. That's where it produces the best gas. Above 10 in the 12, 15 range, that's starting to be overpulling. You're going to move into clinkers, and below 1. It's likely going to get too cool and you're going to start making tar. So we're always trying to have it above 1 and we're trying to have it below 12. Okay, so that's the range. And in the middle of there is the sweet spot. Now it can go higher if the bell starts getting packed, it can go up into this range. And if you start seeing that, that's part of knowing that the bell's packed. Okay, but when it's running well, it should be somewhere below 10 and above 1 or 2, with the stuff in here being correct. So when we're lighting it, the issue is you can't pull it too hard or you're going to blow your flame out as you're starting. So we just pull it a little bit in the beginning as we're getting it lit, and then once we see it's lit, we can increase it a little bit. And we start through this hole until we see it get up to about 100 or 150 degrees, and then we open the real air and shut this. And then once you see the temperature rising again and it's set, then you can really open this up to 5 or 8 inches to warm it up very quickly. Okay? So it's like starting a campfire. You gotta start a little small, you don't blow it out, and then once it gets going, you can be more rough on the fire. Okay? So there's that. You want to make this easy. You get a little squirter with some kerosene, like you're starting your barbecue. You stick a little kerosene in there. Then it goes very, very fast. That's also nice because that liquid will come out as vapors, and you can light the vapors before you're even making gas.
Im Keller gerade Waschbenzin holen.
Okay.
We get a little kerosene.
Okay, and we had a hose here yesterday to do that.
It's on
So
the
there's 2 reasons that it's nice to put a little liquids in here to start it.
Ja, haben wir den Schlauch noch?
We have a Schlauch. We have a hose we can take siphon some diesel.
Herbert, there's 2 reasons that it's nice to put liquid fuel in here to start it. One is that the charcoal starts faster, and the second is that liquid fuel will make vapor, and the fuel vapors come out through here and start this. So it helps to support your flame in the beginning. Before you have good gas here and it's just barely lightable, the liquids will help you to get more, or get a flame assist.
Richtig, richtig. Da verfliegt was und das zündet dann hier leichter.
Haben wir den größten Schlauch noch da?
One more?
Yeah.
Right?
One more?
One more. Yeah.
Don't drink and drive. Don't light your breath.
Oh, sorry.
Two more?
No, that's fine. Good thing.
Okay. Here's some bullets.
Okay.
Let's use that one on here and the other one. Did I begin?
You can get the other one.
And just so everybody knows, if you see any smoke coming off of this, get out of it. Don't breathe the smoke.
Stay out of the smoke.
It's very bad.
No, you don't start that until you get you have the air on. You're pulling gas. So set that to 1 or 2.
Die ejecting? Läuft den Druck noch? Ja.
So Holger, you want to look at the manometer and put it to that marker.
That's why you don't take a full U. I always wondered if you want to depress the pressure.
Hard to tell where
130 bleiben, 60 Ohm. So Herbert, you can turn that off. And then open
But remember, all of our characterizations on these numbers were previously with just the reactor, and we found anything 900 and above was okay. But really, once we've added all this in, it can be lower and still okay. Now, the specifics of those we don't know. So to be very conservative, 900 and above is always great. But once it's running, as long as I see it 800 and above, I'm happy. Okay?
The difference is okay also.
It's usually about 100 differential. Sometimes it'll start flipped over, so the bottom will be hotter than the top. Don't worry about that. Let it run for a while and they'll reverse, set up correctly. It takes a while for the bed to burn in and get into all the proper shapes and the reduction working correctly. And then once you see that, you'll have about 100 or 150 differential across the bed.
That was good?
Nee, das auch.
Yes, you want to do this transition quickly because the pyrolysis smoke starts to come back out there. It's not terrible, you just get smoke. Now leave that shut. Open all the way.
Jetzt starten.
You just crank it.
Yes.
Just crank it and it finds its own mixture.